Dr. P.R. Jayashree, Assistant Professor, Department of Statistics, Presidency College, Chennai. P.R. Jayashree has done her PhD from Anna University and MBA from Alagappa University. She passed joint CSIR, UGC, National Level Test for JRF and Eligibility Test for Lectureship in Mathematical Sciences. Has also done her postgraduate diploma in Computer Management. She has 17 years of experience in teaching and published 14 research papers in international and national level. Has presented, participated and organized conferences, workshops on SPSS and Torah software. She is a life member of Tamil Nadu Statistical Association and Indian Society for Probability and Statistics. At present, she is guiding 2 research students of Madras University.
Welcome to UGC lecture series on mathematical sciences. Today we are going to discuss about the fundamentals of hypothesis testing. We are going to discuss on inferential statistics, testing of hypothesis, one-tail and two-tail test, type 1 and type 2 error, p-value and some illustrations on these things, and I will give you an assignment. In my previous lecture I have discussed on population, sampling distribution and then the parameter and statistics. We all know the population is nothing but the units, total of all units under study. Sample is nothing but a subset of these population, and sampling distribution is you need to take the samples of the same size and then you have to form a distribution for that, and we call that as a sampling distribution. We also know about the standard error, which is nothing but the standard deviation of the sampling distribution. We also discussed the sampling distribution for proportion and normal distribution. As I said, parameters are nothing but the population constants or some measures we calculate from the population, and statistic is nothing but the term which is calculated from the sample, or it is a sample measure. We also call it as the sample constant. As we have for the population, we always denote the population parameter in Greek letters and the sample parameters in the alphabet term. So what is this inferential statistics? Statistical inference is nothing but it is used to decide the characteristic of the population based on the sample study. So as I told you, the sample is nothing but your subset of the population, and if you want to infer about the population, you can take a sample and then under the sample we can discuss about the population. There are 2 forms of statistical inference. One we call it as the estimation, the other one is the hypothesis testing. Estimation is nothing but whatever you calculate from the sample or whatever measure you find out from the sample, we call that as an estimated value. So when we have an estimated value, definitely it is only from the sample and it is a representative of the population. So what we need to do is we have to do the hypothesis testing. We need to do a testing on the sample statistic. So hypothesis testing is nothing but testing the sample statistic for the population parameter, and this is very important, as in the surveys we generally use descriptive statistics and the inferential statistics. So what is the procedure of this hypothesis testing? There are about 5 steps you need to deal when we go about the hypothesis testing. Number 1 is framing of hypothesis. Number 2 is you need to frame a test statistic or should have a test statistic based on your hypothesis. And the third one is you need to find a calculated value from the test statistic. And then you need to find a table value corresponding to the sampling distribution of your study. So then you have to make inferences based on your calculator and your table value. So this is the 5 steps to be followed for any hypothesis testing. So the procedure once again I will repeat. You need to frame the null and alternative hypothesis. We will see one by one each step later. The second one is you need to calculate your test statistic, and based on your test statistic you have to find your table value corresponding to sampling distribution. Then compare your calculated value with the table value at alpha % level of significance. If the calculated value is less than the table value, accept your H0, otherwise reject it. So we will see what is null, alternative, what do we mean by test statistic, how do we compare, etc. in this lecture. The first step, as I showed you, is the hypothesis. It is nothing but a statement regarding the unknown population parameter based on the sample data. So, it is nothing but a statement. It is an assumption about the population under study. And we need to frame two types of hypothesis always. One we call it as a null hypothesis, the other one as the alternative hypothesis. So, whenever an hypothesis with no difference, we call that as the null hypothesis. So, it is a statement with no difference, and alternative to this null hypothesis we call it as the alternative hypothesis, and it is an contradictory to the null hypothesis. We also have simple and composite hypothesis under the null and alternative. So, if the hypothesis specifies completely about the population, we call that as a simple hypothesis. Otherwise, it is said to be composite hypothesis. Let us see an example. If the heights of the college students are normally distributed with mu is equal to 155 centimeters and sigma squared, that is your variance is 4, then H naught is there is no difference in the heights of the students, that is mu is equal to 155. So, mu is nothing but your population parameter, and we assume that as 155 centimeters, and sigma squared equal to 4. So, if you see here, it completely specifies, that is exactly it is equivalent to 155, therefore, it is a simple hypothesis. Whereas, if my null hypothesis is greater than 155, then we call that as a composite hypothesis. That means any number greater than 155, we call that as the composite hypothesis. Next, we will discuss about the one-tailed and two-tailed test. A two-tailed test always divides the sampling distribution into two halves, placing half in each of the tail. The null hypothesis is a particular value, and there are two alternative hypotheses, one with the positive and one with the negative hypothesis. So, if my null hypothesis is mu is equal to 55 and my alternative is either mu less than 155 or greater than 155, then we call that as a one-tailed test. So, if it is not equal to 155, then you can also specify that as less than 155 or greater than 155, then it will become a two-tailed test. So, if you are dealing in my alternative only one side, that is mu greater than 155 or mu less than 155, then it will become a one-tailed test. If I did not specify that in my alternative, and if I take it to be not equal to, then we call that as a two-tailed test. So, always in my two-tailed test, there will be two critical values, that is Z critical will be on both the sides of my distribution, and it will be on plus or minus Z critical. So, for example, a critical value of Z when there are 10 degree of freedom is said to be 5% level of significance is Z critical is equal to plus or minus 2.28. So, we will see that in a figure. So, this is my normal distribution, and if you see here the two-tailed test, mu is equal to mu naught, and in my alternative you see that mu not equal to mu naught. That means this mu naught can be less than or it could be greater than value of my population parameter. So, this will either lie in my left hand side of my normal distribution or it can lie in the right hand side of my normal distribution. So, it takes both the values minus 2.28 and plus 2.228. So, let us see some more examples on two-tailed test. Test whether there is any difference in the scores obtained by 100 students is again a two-tailed test, because if you see here there is no difference in my null hypothesis, my alternative hypothesis is it is not equal. So, therefore, if you see here there is no difference between the two mean scores of the students, then mu naught is equal to mu 1, and if you see in your alternative there is difference between the two mean scores and it is mu naught not equal to mu 1. That means you can either state that mu naught is less than mu 1 or mu naught is greater than or equal to mu 1. So, it happens on both the sides of my tail, therefore, we call this as a two-tailed test. So, as I told you, one-tailed, in your alternative, if your mu 1 is less than mu naught or mu greater than mu naught in my alternative, so you will have either less than type or a greater than type in your alternative hypothesis, then it is always a one-tailed test. So, in my two-tailed, if you see it will be mu1 greater than mu naught or mu1 less than mu naught. So, both the things will happen in my alternative, then it will become a two-tailed test. If you have only one side of the tail in my normal distribution, then we call that as a one-tailed test. So, a one-tailed test can be a left-tailed test or a right-tailed test. So, either it will happen as a left-tailed or it will happen as a right-tailed. Only one case will happen in my alternative, and if you see in your null hypothesis, there is always no difference. Now, examples of my one-tailed test whether there is any improvement in the training program or whether the scores of the students after the training program is greater than before the training program is always a one-tailed test. So, if you see in my null hypothesis, always it is of no difference. So, there is no difference in the mean scores of the students. That means before training as well as after training they are equal in my null hypothesis, whereas in my alternative if you see the mean scores after training is more than the first, that is in your H1 mu2 is greater than mu1. So, therefore, we are considering only one case of this, therefore, it is a one-tailed test. So, I have given you the difference between a one-tailed and two-tailed in this table. One-tailed, if you see here mu less than mu naught, that is it lies only in the left hand side, and if you see in your two-tailed test it is not equal to, that means it lies both in both the tails, therefore it is a two-tailed test. And if you see here this is a right-tailed test, that is mu greater than mu naught in my alternative hypothesis. So, next comes the test statistics. So, first step as I told you, you need to frame the null hypothesis and alternative, and it could be a one-tailed or a two-tailed test. So, one-tailed or two-tailed based only on your hypothesis testing. So, next step is to framing the test statistic. As I told you, test statistic is nothing but the sampling distribution of the sample statistic with the population parameter. We always have the test statistic like this. It is not necessary always you should have a Z. We normally use the Z only for the large sample test. It could be T, F or chi squared. Based on the sampling distribution, this test statistic will differ. So, we always have the test statistic as x minus expectation of x divided by standard error of x, and this x is nothing but your sampling distribution. You need to take mean of your sampling distribution and then the standard error of the sampling distribution, and as I told you, standard error is nothing but the standard deviation of your sampling distribution. So, you need to find your mean, you need to find your standard deviation of the sampling distribution. So, if you know your mean and the standard deviation for the sampling distribution, then you can frame the test statistic. So, I have given you an example for framing the test statistic. This is a normal distribution, we are taking a large sample. So, for example, to test whether there is any difference in the sample mean and the population mean, then the sample mean is also a normal distribution with mean, mu and standard deviation as sigma by root n. So, sigma is the population standard deviation, then your standard error will be sigma by root n. So, I told you, you have to frame your test statistic as Z stat, that is your x bar is your sample mean for your sampling distribution and mu naught is your population mean divided by the standard error of your sampling distribution. Here the sampling distribution is x bar. We already discussed the standard error of x bar is nothing but sigma by root n. Then what you have to do is the value you have to calculate from this test statistic, and we name it as the calculated value of the sampling distribution. The next step is to find the table value for a given level of significance. We will discuss this level of significance later in my lecture. So, first of all, what you have to do is you need to calculate your test statistic, and this we call it as a calculated value, and then you need to compare that with the table value at a given level of significance. If the calculated value from the test statistic is less than the table value, then you accept H naught, otherwise reject it. So, as I told you, before going into the level of significance, we will discuss about type 1 and type 2 error. So, why this error occurs? First of all, I will define what is type 1 and type 2 error, then I will give you an example what is this exactly type 1 and type 2 error. So, normally type 1 error is nothing but rejecting a null hypothesis, but actually it is true. So, this will happen because we are dealing only with the samples, we are not dealing with the population. Therefore, actually the null hypothesis is true, but what we have done is we have rejected it. So, it is a major error occurring in the sampling form. Therefore, this we call it as the type 1 error. One more error can also happen in sampling, which we accept the null hypothesis, actually it is false, and we call that as the type 2 error. So, if you are rejecting it, actually if it is false, then it is a correct decision. Similarly, if you are accepting the null hypothesis when it is true, is a correct decision. So, these two are the two types of error. So, we will see an example. What is this type 1 and type 2 error? Suppose that an accused individual is judged in a court of law. We want to test the hypothesis that he is innocent H0 and guilty under H1. So, it is not necessary that always this guy should be an innocent guy, and we have to accept that. Okay. So, there are 4 possible cases arise in this example. We will see one by one what are the possibilities arising in this case. The first one is the person is innocent, that means my H0 is true, and the judge finds that he is innocent. That means you accept after doing some analysis, that is you carry out your you frame your null hypothesis, frame the test statistic, and then compare your calculated table value, and then you accept it. So, actually he is an innocent guy, therefore you are accepting it, therefore it is a correct decision. So, what you have carried out in your analysis is a correct one. The other one is the person is innocent, that is your H0 is true, but what the judge does is he finds that he is guilty, therefore he rejects the H0. And if you see here, actually that guy is a innocent guy, but the judge has rejected that guy as a guilty guy. So, this is major error and we call that as a type 1 error. Next one is, next possibility is the person is guilty, that is H1 is false, and the judge finds that he is an innocent guy. So, that means actually he is a guilty guy, but what the judge has done is he has found that he is an innocent guy. So, actually H0 is false, but he accepts H0. So, if you see, this is also a major error and we call that error as a type 2 error. So, if the person is guilty, that is a H0 is false, and the judge finds the guilty, finds that he is guilty, then he rejects H0. So, both this is false as well as he rejects it, then it could be a correct decision. So, there are 2 types of error always happening in any sampling distribution. So, we generally denote the type 1 error as alpha and type 2 error as beta, and we call this as the alpha error and this one as the beta error. So, as I told you, if you accept H0 when H0 is true, it is a correct decision. Similarly, if you reject your H0 when H0 is false, is also a correct decision. But when you accept H0 when H0 is false, it is a type 2 error, and rejecting your H0 when it is true is a type 1 error. As I told you, we call this as the alpha error and this as the beta error. So, if you see here in my example, as I told you, this is an example which we have taken for type 1 and type 2 error. If you see here, so do not reject your hypothesis when it is true is 1 minus alpha. So, these are the probability values, I mean these are the alpha values which lie between 0 and 1. So, I am going to attach the probability also along with this alpha and beta, and if you see here no error is there, that means 1 minus alpha means you have not made any error, whereas in the second one you are making some error. Similarly, in my rejecting H0 when it is true also you are making some error, and this is no error. So, 1 minus alpha and 1 minus beta are with no error, that is you have taken a correct decision based on your sampling distribution, because if you are taking a sample, it is nothing but a representative of the population. Therefore, you should be very careful that you are doing a correct decision, you are taking a correct decision based on your test statistic. If you are making this one error, then we call that as a beta error and the alpha error. And if I attach some probability with this one, so probability of type 1 error we call that as the level of significance. So, you can allow this error to happen to some extent. Generally, we allow it to 5%, 1% or 10%. So, this is nothing but probability, that is chance of happening of this error is nothing but the level of significance. Similarly, you can also have the probability attached to beta value, which is nothing but probability of type 2 error, and 1 minus this probability we call as the power of the test. So, as I told you, type 1 error, we have this alpha we can allow it as 5%. So, in general, globally accepted value is generally we always have alpha to be 5% level, that is you allowable error to happen in any sampling distribution of test statistic. So, if you are dealing with any hypothesis, 5% is the globally accepted error to be allowed. So, that 95% of your sampling value or the test statistic you are carrying will be correct decision. So, it is a minimum allowable error by any researcher. So, generally as I told you 5%, 10% or 1%. So, based on your calculated value you can see your percentage of error also, and you can see how much it is significant your sample values. So, another type of error, as I told you, type 2 error made when we accept the null hypothesis, that is false, and this beta is the likelihood of making that beta error. Controlling this error is more complicated than controlling the alpha error. So, what we can do is to control this error, you can increase the sample size. So, by increasing your sample size, you can always minimize this alpha error as well as your beta error. Now, we will see an example on how to do this hypothesis testing, how to go about the 5 steps in hypothesis testing. I am not going in detail about the test statistic, because test statistic is a very crucial part in finding any hypothesis testing. So, this is only an example to know how should be testing of hypothesis carried out in all the 5 steps. So, let us take an example. A random sample of n equal to 50 measurements of a product from a population having, and this is x bar is nothing but your sample mean, which is equal to 12.6, and the standard deviation for this is 0.7. That means, we have taken a sample of 50 from the population and we have found the sample mean and the standard deviation. So, this standard deviation could be a population standard deviation or it could be a sample standard deviation. So, the test is, can the population mean mu is equal to 13 coincides with the sample mean. So, that is what we are going to compare here, whether the population mean is equivalent to the sample mean or not. So, hypothesis, as I told you, you need to frame the null hypothesis, and the hypothesis here is mu is equal to 13 versus H1 mu not equal to. So, we are not having any resemblance of type, single tail or two tailed in your question. You need to find out whether it is a two tailed test or a single tailed test. We do not have any greater or less than in my question, therefore, I have my alternative to be mu not equal to 13. So, that means it is a two tailed test. So, as I told you, we are assuming that the samples are drawn from a normal population, and I know my population standard deviation as sigma equal to 0.7 inches. And my alpha level, as I told you, it is a globally accepted one, 5% level of significance. The test statistic for this type. So, I am not going into detail how this has come, but for any normal distribution, the test statistic for testing the single mean, it is Z equal to x bar minus mu by sigma by root n. And if I want to calculate the Z value, just post your x bar value, mu value, and then your standard deviation, population standard deviation divided by your square root of the sample size, and I have 2.86. So, now my mu is equal to 13, and this I have to compare this calculated value with the table value of Z, and the table value of normal distribution here, it is 1.96. Since my calculated value is greater than the table value, always you have to reject your null hypothesis. So, null hypothesis is rejected in this case, since my calculated value is greater than the table value. So, this is an example how to carry out a testing of hypothesis. Another approach is there apart from your calculated and table value, which generally we call it as the p-value or probability value approach for this hypothesis testing. And this p-value is nothing but the maximum probability of type 1 error. You can calculate this p-value by using calculator or computer, and as I told you, this is nothing but the maximum possible probability of your type 1 error. As I told you, type 1 error is nothing but the allowable error, that is your rejecting H0 when it is true. So we need to calculate this p-value. Another way of looking this p-value is the probability of observing a sample observation from the population parameter is true or not. So this p-value, instead of going into detail with the calculated and table value, we can also compare this p-value with our probability value in the test statistic. So this p-value is, as I told you, it's a probability value, is the smallest value of alpha for which H0 is rejected based on the sample data. So as I told you, it is based on your alpha, that is your level of significance. So convert your sample statistic, that is sample mean, to a test statistic, which is nothing but a Z statistic. So obtain this p-value from either a table or from the computer. So you can generate, you can find the p-value from the computer. So by using SPSS, so many software packages are available to find out your p-value. So if you know your p-value, how to conclude or how to find, how to accept or reject a hypothesis is compare your p-value with always your alpha, which is nothing but level of significance. If your p-value is less than alpha, reject H0, otherwise you have to accept your H0. So do not reject your H0 if your p-value is greater than or equal to alpha. And alpha, as I told you, it's a level of significance, you can take it to be 5%. So summary of my testing of hypothesis lecture is that we have discussed about the null hypothesis, we have discussed about the alternative hypothesis, and as I told you, you need to gather data, you have to collect the samples to determine whether the evidence is strong enough with respect to the alternative to reject the assumption by using the test statistic. So our aim is to reject a hypothesis based on the test statistic. So if the sample observation is in favor of the alternative, then the null hypothesis is rejected, otherwise it is accepted, that is my H0 is accepted. What we have discussed in this lecture is, we have seen what is the procedure of carrying out our test of hypothesis. You need to frame your hypothesis, you need to find the test statistic, you need to find a calculated value from the test statistic, and then you have to compare your calculated with the table value either to accept or reject our hypothesis. So for your inferences, you can either use a calculated table value or you can use your p-value. So I have some questions based on the lecture. A random sample of 10 males has the following weights. So I have given the 10 data with the weights and it's a sample value. Do these data support the assumptions of the population mean height greater than 100? So this is the question based on the test of hypothesis. What you need to do is, you have to frame the null and alternative hypothesis, check whether it is a simple or composite hypothesis, check whether it is a one-tail or two-tailed test. Thank you.